So far, our discussions of Spark have focused around the RDD. And while the RDD is kind of the fundamental abstraction of Spark, it turns out that there are newer ways of working with Spark that are generally recommended for the end user. In many ways, the RDD is still sitting there under the hood, but one of the challenges with RDDs is that the optimization of an RDD and the RDD operations falls on the shoulders of the programmer. And this is because, in some ways, the strength of the RDD is the fact that they can hold any data, and the functions that they work on, the lambda expressions that you pass to them, are arbitrary functions. They can do anything that you want. That's great for you, potentially, as a programmer, but as far as automatic optimization goes, it removes a lot of the possibility for automatic optimization because Spark doesn't know what your functions are doing. When you call a map and you pass it a function, it doesn't know what you're going to do. It doesn't know what parts of the data you're going to work with. It doesn't necessarily know if it's going to have to reshuffle data. There are lots of challenges in there. For that reason, they created a newer library called Spark SQL. And this API for working with Spark generally gives Spark more information about the data that you're working with, and it allows it to do many optimizations, and many of those optimizations actually come from research in databases, which is part of why the SQL is part of the title there. So how do we work with Spark SQL, and what exactly goes into it? So I have the API here, and I am on the org Apache Spark SQL package. This is where the kind of foundational classes for Spark SQL are located. There's actually a number of sub-packages under here that will use some of them. In the original version of Spark SQL, there was an entity called a data frame, which you can see right here, type data frame, that was kind of a replacement, as far as the end user was concerned, for an RDD. This has since been updated. Instead of having a type for a data frame, there is now a type called data set, which you can see here in the API, and you can see that data frame is nothing more than a type alias for a thing called a data set of row. We'll talk about data sets later, but we're going to focus in the first videos on data frames and how we can work with them. Now, these data frames use rows. Rows, by their nature, they hold a row of data in a way that is not necessarily type safe. And this is one reason why data frames are somewhat of a significant deviation from the RDDs and from kind of the general way that Scala approaches things. Scala code typically tries to make everything type safe. There are lots of aspects of when you use the data frames and Spark SQL where things aren't checked at compile time. Also, the operations that we do on data frames and actually on data sets are more like those that you do on databases. They kind of resemble SQL. If you're not familiar with SQL, you might actually want to brush up on that some before going and looking at some of the videos later in this video series. And because of that, they're able to do these optimizations, which people have developed literally over decades of researching on databases. So I just want to start writing a little code that uses Spark SQL instead of the RDD interface. And the first thing we have to do is, when we were dealing with RDDs, the first thing we did was we made a Spark context. In this case, the first thing that we need to do is get a Spark session. Spark session is kind of our replacement for a Spark context, but not really, because it turns out there's a Spark context there. In fact, there is a method down here called Spark context, where you can get the Spark context that is associated with a data frame. And so what I'm going to do here is I'm going to make a new package. I'm going to call it Spark SQL to kind of keep things separated here. We have our RDD examples. And inside of here, I am going to make a new object. We're actually going to play with a different data set here because it highlights some of the strengths of Spark SQL, I think, a little bit better. So I'm going to call this NOAA data. Once again, it's weather data, but it's from a different source. It's actually a much bigger data set, and so you'll be able to download it and play with it yourself. And I want to go ahead and create a Spark session. I'm going to call it Spark, and this is actually fitting with what it's called in the Spark shell. It's kind of just a standard name that has been associated with these Spark sessions. And when we import this, you'll see there's a method called builder. And so I'm going to get a builder, and there's a number of things we can do with these builders. We can give them configurations and whatnot. I'm going to go ahead and have my builder, I'm going to set the master to be local. There are other types of configuration things that we could do. Actually, let's go ahead and give it an app name. We'll call it NOAA data. That way, if we were to ever go look at what's happening on our Spark cluster, we'd be able to see that. And then there's this method get or create that will either find an existing Spark session that we could use or make a new one for us. After we have the Spark session, it turns out the Spark session also has a number of implicit conversions that are very helpful for us. So as soon as we create this, we are generally going to import spark.implicits._ because there are aspects of that will be helpful. So we have this set up. I'm going to close off this video here. We'll come back, we'll look at the data set, and we'll also talk about the data frames a little bit more and see how we can get things into data frames and how we need to create schemas that help Spark to know what type of data is in our data frames.